All right, MEFB 2013 Manufacturing Processes class. Welcome back. Okay, so yesterday, if you remember clearly, we spoke about uh, the different important concepts in welding. I told you that the most important element in welding is the type of electrode that you use. So there was three: the bare electrode, the light or flux coated electrode, and the contact electrode. And besides that, we went through four different major points in welding, which is the welding speed, okay, your welding speed, the overhead welding. If you remember, we spoke about the welding speed, using of fluxes, the welding shape, and most importantly, welding position, and the storage time before welding, meaning that the time between the taken to after cleaning the workpiece and using it for welding. Yeah, so all these factors play a very important role in ensuring that the welding process is successful and it does not have any oxides that is trapped within the weld area itself. Okay, so our biggest challenge, like I mentioned to you in the last class, was the presence of oxides, or in layman's term, the formation of rust in the welding zone. So let's look at the different types of welding processes now, and also the shortcomings or the ways or the techniques used to overcome the formation of rust in the workpieces. Yeah, so and like I mentioned to you, each and every welding processes has got a protective mechanism. It may be internal or external. So number one, the type of electrode used matters. So if you choose to use a bare electrode, then you have to have an external protective mechanism like supply of gases, or some other protective mechanisms to protect the weld area from oxidation. Otherwise, if you choose to use coated electrodes, be it a flux coated electrode or a contact electrode, a heavy coated electrode, then you do not have to worry about protective mechanism to protect the weld area, because this coating has got constituents that will release and protect the weld area from oxidation. So the first, let's look at the first process, atomic hydrogen arc welding. What is atomic hydrogen arc welding? Atomic hydrogen arc welding, in this type of arc welding, the arc is formed between two tungsten electrodes and not between one electrode and the work. Okay, so we are not interested in the concept of arc welding. You already done it in your manufacturing processes lab. So I'm just more concerned about the how the process works, and the highlight of this process, and the mechanism used to protect this process from oxidation. So in atomic hydrogen arc welding, if you look at it, you have the welding process. You're using tungsten electrode, and this is your filler metal. So right now, as you are welding, you will find that during the welding process, you're going to supply hydrogen gas. What is the role of hydrogen here in this process? Yeah, so if you look at it, like I mentioned to you, yeah, atomic hydrogen arc welding. So you see the key word there, hydrogen. So hydrogen has a big role in this welding process. What is the role of hydrogen? Hydrogen acts as a protective mechanism for the weld area. So what happens is, during the welding process, when intense heat is created and hydrogen gas is supplied to the weld area, due to the high heat, hydrogen molecules are converted to hydrogen atom. Hydrogen molecules are converted to hydrogen atom, and this causes intense heat in the weld area. So this intense heat temperature can go up to 6,100 degrees Celsius. So at a temperature of 6,100 degrees Celsius, you can do a lot of things. What are they? Okay, so number one, you get high heat concentration in the weld area. And because of this high heat concentration up to 6,100 degrees Celsius, you can actually weld many alloys that are hard to weld, that couldn't be welded in the normal welding procedure. So if you remember back in the unit 4, we spoke about metals, yeah? You spoke about metals, and I told you there's two category of materials, the brittle and ductile. You have the overly ductile material and overly brittle material in the extreme cases. So in the case where if you're dealing with an overly brittle or overly hard material, when machining is a big challenge, welding is also an equally big challenge. So you would need very, very high temperature concentration in order to weld this kind of material. So there you have atomic hydrogen arc welding to assist you in this kind of welding processes. Secondly, what is the role of hydrogen? Hydrogen acts as a shield to prevent oxidation and protect the weld area from oxidation. So if you observe, hydrogen is being supplied during the welding process. Hydrogen creates a gaseous shield around the weld area and protect it from oxidation. And if there's any impurities present, the hydrogen would actually absorb all these impurities, and it will float on the surface of the weld, which during welding, after the welding process, you're going to use a hammer, knock on the surface of it and remove that slag, and then you get your shiny surface of weld ready. Yeah, so that is atomic hydrogen arc welding. Okay, let's look at the second welding process, inert gas shielded arc welding. What is inert gas shielded arc welding? Another typical arc welding process, but if you see the keyword here, use inert gas. Okay, so it clearly states here that inert gas is going to play a part in this welding process. Then you see the two categories of welding, which is tungsten inert gas welding, metal inert gas welding. So you have the tungsten and the metal. What are these tungsten and metal referring to? You're referring to a tungsten electrode and a metal electrode. Okay, so you're either going to use a tungsten based electrode or a metal based electrode. So if you look at the description, yeah, for tungsten inert gas welding, inert heat is created between a non-consumable tungsten electrode and the wood. What do I mean by non-consumable tungsten electrode? Okay, so if you recall back, during your manufacturing process, you used an electrode, and then electrode, as you welded, became smaller and smaller and smaller, and at the end you have a very tiny piece of electrode which you threw it away, and then you replace the stick, yeah, until your whole welding process completed. So if you see the electrode becomes smaller and smaller in size, we call it a consumable electrode, where the electrode is actually consumed, melted and deposited into the weld area. We have another category of electrode, the one that you see here, yeah, a non-consumable electrode. What is a non-consumable electrode? A non-consumable electrode is an electrode. A non-consumable electrode is an electrode that is not consumed or not being used. Meaning, okay, this is a different process, but I want to use this as an example because there's a non-consumable electrode here, yeah. So if you look at this, you have a flux hopper, you have a wire reel. So electrode is coming in the form of a wire reel because again, this kind of, when you're dealing with mass production, you want continuous supply of electrode. So if you were to use the stick one by one, it's going to take you forever, yeah. So you have electrode coming in the form of a wire or reel. So if you see, this wire or reel goes through a wire drive control, okay, a wire drive control, and then it goes through your electrode here. So is this electrode going to be melted? No. What is being melted? The wire reel is melted and deposited into the weld area. Therefore, we call this electrode a non-consumable electrode, meaning that you're not going to use this electrode in the during the welding process. It's just there like a dummy electrode, yeah. So back to the previous discussion, yeah. So you have tungsten inert gas welding and metal gas welding. So intense heat is created between for tungsten, yeah. Intense heat is created between a non-consumable tungsten electrode and the wood. A mixture of inert gases. So here, like mentioned, a mixture of inert gases, argon and helium is supplied to shield the work. So what is your protective mechanism here? argon and helium is used as a protective mechanism. Anybody, what is an inert gas? Okay, so an inert gas is a non-reactive gas, a very stable gas. So it will not react with any substances. Therefore, it is very safe to be used as a protective mechanism. So in tungsten inert gas welding, you're going to use tungsten as an electrode. In metal gas inert welding, you're going to use metal as an electrode. And when I say consumable, it's like the one you did in the lab. Yeah, your electrode gets consumed, eaten up, and being deposited into the weld area. Whereas for continuously fed, for a non-consumable electrode, is the one that I just showed you, where you have a dummy electrode and you're going to feed a wire through that dummy electrode, and the wire is the one that is going to be melted and deposited into the weld area. So that basically ends this chapter. We spoke about 2 welding processes. Please go through, try to understand these 2 welding processes, because when I ask you in your exam or in your assignments, it will be in the form of a case study. So please remember atomic hydrogen arc welding, inert arc welding. That's all for today. Thank you very much. I'll see you in the next video. Please don't forget to complete your assignment 3. I will see you then. Thank you.